Hi everyone, this is the second video on how to find out which bisector is the bisector of the pair of acute angles and which one is the bisector of the pair of obtuse angles. In the previous video we have discussed about method 1 and in this video we are going to discuss about the second method where we will be using another technique to find out which bisector is the bisector of the acute angles and which one is the bisector of the obtuse angles. As you can see in the diagram, I have taken two straight lines. It's pretty much similar to the previous video. I have kept the same diagram here, straight line A and straight line B, and I have their equations written on the diagram. Also I have the equations of the bisectors which are B sub 1 and B sub 2. Here in the diagram, B sub 1 is the bisector of the pair of acute angles and B sub 2 is the bisector of the pair of obtuse angles, and I have their equations also written down over here on the screen. After simplifying, let's assume that finally we get the equation of the bisector B sub 1 as A sub 3 times x plus B sub 3 times y plus C sub 3 equals 0, and B sub 2's equation can be assumed as A sub 4 times x plus B sub 4 times y plus C sub 4 equals 0. For demonstration purpose, I have simply assumed that B sub 1 is the bisector of the pair of acute angles, but that may not be the case always, right? But this is just for demonstration. I have simply assumed, but my assumption could be wrong. B sub 1 could have been the bisector of the obtuse angles as well. So in this case, let's proceed with this diagram and see what we can find out. Next, what I am going to do, I am going to pick a point on straight line A. Let's suppose that the point is Q and its coordinates are h, k. And then from Q, we are going to drop a perpendicular onto the bisector B sub 1 and also onto the bisector B sub 2. And let's assume that the perpendiculars landed on the point R and S. And let's also give a name to the point of intersection of the two original lines, and let's call it as point O maybe. So I'm writing as O right here, and that would be this central point right here. That's the point O. Now if you look at the quadrilateral OSQR, it looks like a rectangle and actually it is a rectangle, but we are going to prove it. This angle is a right angle right here. I'm now going to use the pink color. So that's a 90-degree angle, which is angle ORQ, and similarly angle OSQ is also another 90-degree angle. And also in a previous video we have proved that the two bisectors are always perpendicular to each other. That means angle ROS will also be a 90-degree angle, and then obviously the remaining angle, which is angle SQR, that will also be a 90-degree angle. So then clearly the quadrilateral OSQR is nothing but a rectangle. That means OR will be equal to SQ. Now if we look at the triangle ORQ or OQR, and if we assume that this angle is alpha over 2 or half of alpha, assuming alpha is the acute angle between the two original straight lines, let's assume this is half of alpha. So I'm writing it right here, half of alpha. So then tangent of half of alpha will be equal to QR over OR, and since alpha is an acute angle, half of alpha will obviously be less than 45 degree. That means tangent of half of alpha will be less than 1. So we can say that this is less than 1, and from here we can say that then definitely QR is less than OR and OR is equal to SQ. So we can say that QR is clearly less than SQ. And this is the main concept that we are going to use in this video to identify which bisector is the bisector of the acute angle and which one is the bisector of the obtuse angles. So our next task would be to find out these distances, the distance QR and QS or SQ. So what would be the distance QR? Well, QR will be like this, and similarly the distance SQ will be kind of like this. And after calculating these two distances, if we find that QR is less than SQ, then obviously B sub 1 represents the equation of the bisector of the pair of acute angles, and then B sub 2 will be the bisector of the obtuse angles. So let me make a quick note here, and if it happens to be the other way around, after calculation, if we find that QR is greater than SQ, then obviously B sub 1 will be the obtuse angle bisector and B sub 2 will be the acute angle bisector. I hope everything made sense so far. Next we are going to take an example. Suppose we have been provided with the equations of two intersecting non-perpendicular straight lines, and their equations are like this. And then what would be the equations of the angle bisectors? Well, they will be like this. Using the plus sign, let's assume that that's the equation of the bisector B sub 1. And if we simplify this, the equation will actually turn out to be something like this. I have used the exact same example in the previous video, and if you simplify this, the equation will be 27 times x plus 99 times y plus 70 is equal to 0. And that is the equation of one of the bisectors. Let's try to find out the equation of the other bisector. And if we simplify this, the equation is going to be like this: 77x minus 21y plus 60 equals 0. Next, we are going to pick a point on one of those lines. Let's say the first line maybe. Let's pick a point there. I'm going to make it kind of easy. So let's assume that the point is Q here, and let's take x coordinate as 1. So if we take x coordinate as 1, then it would be 4 plus 3 times y plus 5 equals 0. So that would be 3 times y plus 9 equals 0. So that would be y equals negative 9 over 3. That would be negative 3. So the y coordinate would be negative 3. I arbitrarily picked a point. I said, well, if we assume that the x coordinate is 1, what would be the y coordinate? I quickly calculated from the equation of the first straight line in this example. Right? Next, we need to calculate the distance of this point from the bisector B sub 1 and also the distance of this point from the bisector B sub 2. And then based on that, we will be able to decide whether B sub 1 is the acute angle bisector or obtuse angle bisector. So let's now calculate the two distances. And if you simplify this, this will turn out to be 1.949. And then let's calculate the distance of Q from the bisector B sub 2. And if you simplify this, this will turn out to be 2.506. And now, as you can see, which distance is larger? Well, distance of Q from the bisector B sub 2 is greater than the distance from the bisector B sub 1. So then we can clearly say that B sub 2 is the bisector of the obtuse angle and B sub 1 is the bisector of the acute angle. I hope everything made sense so far. In the next video, we are going to discuss about the third method of identifying which bisector is the bisector of the acute angles and which one is the bisector of the obtuse angles. Thank you for watching. See you in the next video.